Okay, so I'm sorry again that the first part was not recorded, but it's not a big deal. Yeah, the first part was not recorded. I'm surprised too, but we can like catch all of these on the example. Okay? So now let's start with a simple example. The simple example. So let's imagine that we got a simply supported beam, and let me check again if it's recorded.
It's like
Okay. What? Perfect. Check it. Okay. So please. Shh. We have a simply supported beam. This beam have a hinge and the ruler support, and we have a load like this. This is how much? Let's put it 20. 20. Come in. 20 kilonewton per meter, and the length here 5 meters. Let's start with this one. It's a very simple, very direct to the point, and you can understand the basic concept from it. Okay? Now, this is the point A. This is the point B. Okay, what is the first step? Tell me.
find reactions.
Find the reactions. Okay, what is the support here?
First we have to convert endpoint.
What?
We have to convert the distribution point.
Okay, yes. To find the reaction, we should convert it. Okay, but it's an obvious point now. So here now we have AY and we have AX, and here we got B1, right? We got a B1. Okay. So let's find the reaction. And here, because we have a distributed load, we should convert it into point load according to find the reactions. Okay? So here it's a load, and the point load should be equal to 20 multiplied by the 5, so it will be equal to 100. 100. Okay? And the distance will be 2.5 from each side. 2.5 from each side. So, to find the reactions, first of all, let's apply the equilibrium equation. The first one is the summation of the moment on the x should be equal to 0. Hence, AX will equal to 0. Because we don't have any forces on the x, and it's only AX, so AX will equal to 0. This is the first equation. The second one, the summation of the forces on the y should equal 0. It's outward. Okay, what are the forces on the y that we got? We have AY and plus BY. Both of them are positive because it's upward. What?
Minus.
Minus, yes, minus 100, right? Equal to 0. Minus 100 equal to 0. Okay, so minus 100 is equal to 0, and this is equation 2. Finally, we should find the moment, and let's take the moment at the point A is equal to 0, and the clockwise, it's a positive direction, so what we got? AY and AX does not make any moment at the point A. We have a 100 make a clockwise moment at the point A, so 100 multiplied by 2 by 0.5, and it's a positive. Why positive? Because it's a clockwise moment. And we got a BY. BY make a counterclockwise moment, so it's gonna be negative. Minus BY multiplied with 5 equal to 0. And so on. BY will equal to 50, right? By will equal to 50 kilonewton. By will equal to 50 kilonewton. And it's positive. That means that By it's upward, right? And now, since we have By, if we put it here in this equation, Ay will be 50 again. So we find all the reactions, right? We find all the reactions. And this step is normal for you, because we find a lot of the reaction and it was harder than that. Okay, so up to this point, is there any question? I don't think so. So let's start now drawing the diagrams. Can I? Okay, thank you. Okay, so when you want to draw the diagrams, we will put the lines like this. Here we will draw the shear, and here we will draw the lines. Okay, so here we will draw shear force diagram, SFD. SFD means shear force diagram. Shear force diagram. Okay? And here we will draw MBD. It's moment bending diagram. So here it's a shear force diagram, and this one it's a moment bending diagram. Bending. B. Yes. Okay. It's recorded, right? Yes. So MBD. The D or the B mean it's a bending. Bending. Okay? It's a moment bending diagram. After that, up it's a positive, down is a negative, up for positive, down for the negative. So this is the sign. So this is the line. Anything above this line is a positive. Anything below this line is a negative. As same as for this line. Anything we will draw it up this line, it's a positive. Anything we will draw it below this line, it's a negative. Let's draw them. So, I recommend you to not write anything now. Just focus with me, and I will give you like a chance to write everything. Okay. So now, here we have AY, right? And here we have Q, and both of them was a 50. So. Here, let's start from this point. At this point, on the beam, we have a point A, right? At the point A, there is a load equal to AY, right? And this AY is equal to 50, right? And the rule says, if you have a point load going up, on the shear diagram, go up, right? So I should go up here. I will go up to the point equal 50, right? Because AY is 50, so go up 50 steps. So I go to the 50. Is that right? Okay. Now, after that, on every point here, it's act along this load, right? The distributed load. And the value with this distributed load is equal to 100, right? So, it's 100 downward, right? So, you got positive 50. You have positive 50, focus with me, you have positive 50, and the force acting is equal to minus 100, right? So the result is equal to minus 50, so minus 50, okay? So, I'm here, and according to the rule, if you have a distributed load going downward, you should go in this line, right? So from this point, I should go like this, and this point will equal minus 50, right? Because you start with a 50 positive, right? Positive 50, and the magnitude for this load is a minus 100. So I will go with an inclined line above the point minus 50. Is that clear? Any question? Okay. Now, at the point here, at the point B, we have a Vy, right? It's up, and it's equal to positive 50. 50, but positive, right? So you are here, and you get a minus 50, a plus 50, and it's equal to 0. So, it's 0. Okay? Always, the shear diagram ends with a 0. So, if you like draw the diagram, and the result at the end was not 0, 100% your drawing is incorrect. Always, the shear diagram will end with a 0. Okay? Is that clear?
If at this point dy is, let's suppose it is 60,
It can be 60.
then it will like,
It can be 60. Can't be. If it's 16, that means two things. You calculate the reaction wrong, or your drawing is wrong. One of them can be 60. It should be 15. It should be. Okay? So, this is the shear diagram. This is our new frame. Here it's a positive, and here it's a negative. Is it clear? Simple, direct to the deep of the goal, right? So, let's now move to the moment. Okay? Here, can anyone tell me what is the magnitude for the shear jig? 0, right? It's a 0. Here it's a 0. So, if the shear diagram have a 0 point, we should make a new line and a 0 point, okay? Because this point is very important, okay? This point is very important. The shear 0 diagram, okay? This point we call it, by the way, inflection point. It's inflection point. Okay, so we have inflection point here. What is the definition of the inflection point? The point which the shear is equal to 0. Okay, and when you have it, just draw a new line. Now let's go to the moment. Okay. The definition of the moment, as I said, it's the area under the curve, right? It's the area under the curve. Now here, on the shear diagram, okay? On the shear diagram, we have two curves, right? This is the first curve, and this is the second curve, right? Okay. So, what is the area of the first curve? This one. Can anyone tell me what is the area of this one?
Yes.
Yes, tell me.
X half
Half
multiplied by 50
multiplied by 50
multiplied by 2.5.
multiplied by 2.5. Okay. But the question is, how do you know that this distance is 2.5?
Because we have the
All the
point
way.
load 100.
What?
The point load 100 is 2.5.
Okay, but it's not necessary. Just in this case, we find it 2.5. But if it's like a long beam and we have a lot of loads, it's not necessary to always be the same here in the diagram. Okay, so how we can find it? First, let's discuss how we can find this distance. Okay, so the distance here is unknown, right? Let's imagine we don't know this distance. Okay, so this distance is equal to x. We don't know this distance. So the distance here should be, if this distance is x, this distance is equal to
5 minus 6.
perfect. It's a 5 minus 6. Okay. Because all of this is a 5, right? And this one is x. So the remaining is 5 minus 6. Is that clear? Okay. Now we will use a concept that we use it in school. It's the similarity of triangles. You know this concept?
Yeah.
Okay? So this triangle and this triangle is similar. Okay? 100%. So the height of this triangle is 50, right? Let's write it. Here. Okay, the height of the first triangle was 50, right? And it's divided on its length. The length of the first triangle is x, right? So let's go back. The height is 50, the length is x. And by the similarity of triangle, this should be equal to the height of the second triangle. How much the height for the second triangle? It's 50 always, okay? It's not a minus, because there is no minus sign in this. It's a minus, it's a 50, divided by the length. The length of this one, it's a 5 minus 6. Okay? 5 minus 6. So now you have an equation with the one unknown. You can find x, right? You can find it. So if you find x here, x will equal 2.5. X will equal 2.5. Is that clear?
Yes.
So let's go back again. So x equals 2.5. Perfect. Now, as Michael says, that the area of the triangle is equal to half multiplied by 50 multiplied by 2.5. So the area here, where we should have it here, the area A is equal to half multiplied by 50 multiplied by 2.5.
2.5.
62.5. 62.5. Yes, 62.5. Okay? What?
Same with other plane.
Yes, 62.5. And it's positive, right? So the area for this curve is 62.5. Now, here we are on the 0, right? And the area for this one is 62.5. So I should start from 0 to here, which is 62.5. Okay? So my next destination, my next goal toward to the point 62.5. All of you, focus with me, please. So we find that this one here, it's 2.5. So again, we calculate the area here, okay? The area was 62.5. So I was on the 0. I want to move on 62.5, okay? And according to the rule, I should move with a second degree curve, okay? With a second degree curve. So, how I will move? How I will move? Always to move correctly for the moment, okay? You are moving in the second degree, okay? Second degree or third degree means that you will go with a curve. You should draw the curve, okay? So, to draw it correctly, just imagine that there is a line connecting between the points, okay? Let's imagine that there is a line connecting between 2 points and draw the curve above this line. Okay? You will have it always correct. So just imagine that there is a line between the 2 points that you want to connect it with and draw the curve up to this point, up to this line. Sorry. Okay? Now, the area here, the area for the second curve. If you calculate the area, it will equal to 62.5. Again, but it's negative because it's a negative area, okay? It's negative. So now, you having 62.5 minus another 62.5. So your next destination will be the 0, right? And just imagine that you got, that there's a line between two of them and draw the curve. Okay, but just like in this one. So up to it, it's like this. Okay? So this is, and all the curve is positive here. All the curve is positive. What? Wait a second. And the magnitude here is 62.5. Is that clear?
This point is curved.
What is it? What is your question?
Like how this come like?
Okay, again, here we start with a 0. We calculate the area. It's a positive 62.5. So 62.5 is here, okay? Because this area ends at this point. So I should put the 62.5 here, right? Okay. So now I should move from here to here. And according to rule, because I have a distributed load, I should move like a second degree curve. Okay. Second degree means a curve. The curves, to draw it always correctly with a moment, just for the moment, okay? Just imagine that you have a line and draw it up to it, okay? So, after that, we calculate another area. It's a minus 62.5. You are here. You having a magnitude with a positive 62.5. There is another magnitude. It's a minus 62.5. If you add it to them together, you will get 0. So I should move from this point to this point with a curve also. Okay? So just imagine that there is a line between two of them and make a curve. Just like that. You got it? Any question? Yeah.
Like the other triangle is minus 62.5. So we have to go down minus 62.5.
Yes, here we go up and here we go down. Yes, because this is a minus area and this one it's a positive area. Okay?
No, like for the 62 plus 62.5 is upward. So minus 62 point should be downward. So diagram should be downward from that point.
We go down. We was here. You was here up to this point, 62.5. And you go to the 0. As I said, we go down. It's like this. We go down. Okay, you was asking why not like this. You should know about the integration. Okay, it's a negative slope, and you will get a negative. So it's not gonna be like this. It should be like this. Okay, it's depends on mathematics. Okay, and since you are not like have a good knowledge or good background in integration, just follow this rule. Okay, just imagine there is a line between these 2 points, and draw the curve up of the line, always up of the line. Is that clear? Yes, please.
It's clear, but if we had this view grid is going from downward to the upward, the beam.
Like this?
The beam is there, everything going to be mirrored,
Like this, you mean?
Yes. The same value.
Everything will be reflected.
Mirrored.
Yeah.
Here.
Yeah, even the curve will be like this. Yeah.
So if I'm going to draw the hidden line from the curve, I'm going to draw it downward the line. In this
No,
case.
it should be like this.
Yes.
It can be like this. Let me do that for a second. I get your question. Okay, like this. So it's minus. So like this. It's like this. And it will be like this. This is the omega. It will be like this. Okay?
It's always over the line.
Yeah, it's always over the line. Okay? Just for the moment. Just when you draw the curves for the moment. Okay? Is that clear? Any questions so far? Still recording? Huh? Yes, perfect. Okay, now let's take another example. Are you all right? Okay, take it. By the way, there's two curves after the moment curve. You can draw another two curves. There's a theta curve and deflection curve. But it's not for this course.
There's the solution to solve this.
Yeah, this is it.
We have to, like, in a paper in the exam, we get it. We have to.
Yes, but not like this week. You will have
No, I'm not saying like the steps will be like this. And
yes, the steps will be like this.
Like when we draw the moment pending that's okay. That's the final step.
Yes. Just draw the diagrams correctly and you will have it on. Okay? And you will find in term exam will be 5 questions.
With one option.
One of them like this. One of them is on the trusses, section method. And other three, I don't know.
5 questions?
5 questions and the time is 2 hours. So you will have an
4 questions will be obligatory.
what?
4 questions will be obligatory, one will be optional.
Yes, all the questions will be obligatory. Yes, for sure, all will be obligatory. All will be. I do like to put some questions and there's a one elective and another obligatory, you know. All of them is obligatory. By the way, and there's a homework this week.
This week. You will send us on Friday?
The homework? I don't know. ونهاية كتالي. Did you finish? Can I listen to the board? Thanks. Okay, now let's go with another example, but let's make it more difficult and let's enjoy to do it. Okay. By the way, I'm thinking to change this room. Because if we use like a whiteboard to be like better, right? Okay. And yeah, by the way, can you have a paper and write the date on it? Your names and your Newton code. Say attendances, okay? Just anyone have a paper and pass it between all of you. Write your name, your Newton code, and sign it. Okay? So, another example. Please. Okay. So we have this beam. Okay, we have this beam. And this load is 50 Newton. And we have another loading like this. Oh, we got those. Please. Okay, so the question says, draw the shear and the moment diagram for this beam. So, draw shear and moment diagram. So this is our draw shear and the moment.
Point B is moment.
Yes, I said that before. MBD is moment bending diagram. SFD is the shear force diagram. Okay?
No, point B, there is a moment.
Yeah, there was a moment. Okay.
Whatever.
It's 50 kilonewton. Okay? Now, the first step always is to find the reaction. First step always is to find the reaction. Okay? So for A, we have AY and we have AX, and for F, we have FY. Okay? So let's find the reaction. Tell me. And of course, we have a distributed moment here. Okay? So for this distributed moment, it's a 10 multiplied by 2. 20, and the distance here, it's a 1 meter and 1 meter. 1 meter from each side. Okay? Now, let's find the reaction. Let's find the reaction. So, the first equation is the summation of the forces on X should be equal to 0. What are the forces on the X that we get? What is the forces on the X that we got? 100 sine or cosine, sorry, cosine 30. Yes, it's a positive, right?
Negative.
Yes, negative AX minus AX is equal to 0. So AX will equal to, how much is this? 100 multiplied by cosine 30. Can you calculate, please?
86.6.
86.6. So this is AX. After that, let's apply the second equation. The summation of the forces on the Y should equal 0. Right? What are the forces on the Y that we got?
50.
Minus 50.
Minus 20.
Minus 20. Yes.
Plus
Yeah.
sine 30,
Plus
100 sine 30,
100 sine 30. Okay, what else?
plus Fy,
Plus Fy plus A1 equal to 0. Right? This is the equation. This is the equation. Okay? Finally, the final equation is, let me just erase this one. The summation of the moment at point A, for example, it will be 0. Clockwise opposite. So, AX and AY does not make any moment at point A, right? So what we got? It's a 50 multiplied by 2, right? And it's a positive, so 50 multiplied by 2. We have a concentrated moment. It's a counterclockwise equal 15, so it's a minus 15. And we have a forces equal 20. It's have a distance beside point A equal to 3 meters. So it's 20 plus 20 multiplied by 3 multiplied by 5. Sorry. Okay. And we have this force upward. It's make a minus 100 sine 30. And minus because it makes a moment at point O counterclockwise, and the distance is 8. The X component of the inclined force does not make any moment, 0. And finally, we have Fy makes counterclockwise moment, and it's equal to 10. So minus Fy multiplied by 10. All of these should equal to 0. So please, can anyone tell me what is the value of Fy? 100. Okay. 85. 185 minus 50 minus 215. Okay. 21.5. Is that correct? Okay, do calculate. Who have a calculator? I think it's 21.5. The one? Okay. May I go? So 100 minus 15 is 100 minus, okay, 50 divided by 10. Yes. So as I said, Fy is 21.5 million. Okay. It's 21.5 million. Is the negative sign? Negative sign, yes. Again, Fy here we find it at minus 21.5. The minus sign means that, what is the minus sign mean?
Oh, sorry, the direction is wrong.
That the direction of the foil, it's not up, it should be down. Okay, it should be down. Okay, we find Fy, now we should find Ay. So, minus 100 plus 50, it's a minus 50, minus 50. Okay, so Ay will equal to 71.5 kilonewton. Okay. Oh, sorry, no. So minus 70 plus 50 minus 21.5. Okay. It's 41.5. So AY, we find that AY 41.5. 41. Okay? So we find all the reactions. After we start the reaction, you draw it?
No.
Oh, the tendency. Does anyone who didn't write his name? Okay. Okay, so we find the reactions. Now we will start drawing. Okay? But not on this board. On this board, I think it's better. So here we have AY. And we got AX. AY was 41.5. AX was 68.6. This direction. For Fy, it was like this. Fy will equal to 21.5. So this is it. And we have, this is the point A. There is a point B, point C, point D, A, B, C, and E, finally the point F. The distance between 2 points, any 2 points, was 2 meters. So let's start drawing now, okay? Okay. Let's start with the shear force diagram. Up positive, down negative. Okay? Up is positive, down is negative. What the loads that we got? There was a load like this. There was a counter-clock moment. And there is also a distributed load here. And there's an inclined load here. Inclined load here. Okay. Shall I start? Okay. You shouldn't write anything. Please focus with me. You will have your time to write everything. But focus, because if you have any question, you can ask. Okay? Now, let's start here from the point A. So at the point A, there are two forces, right? One on the Y, one on the X. So, for the X force, is it the shear force?
Sorry.
AX, it's 68.6.
Yes, it is the shear force.
No, it's not a shear force, because the concept of the shear force was, it's the force which is perpendicular to the X. Yeah, AY is it, but not AX. So AX does not affect on the shear diagram, okay? AX does not affect on the shear diagram, because it's act on the same axis of the beam. Clear? Okay, now, AY is the shear force, actually. So AY it's up, right? And it's equal to 41.5. So according to the table that was written here, if you get a force up, just go up with it. So let's go up with it. I will go up with it here to the point 41.1. 41.5. Okay? Now, please focus with me. Don't write. Between point A and point B, between point A and point B, is there any force?
No.
There is no force, right? there is nothing act between this point, right? So I will remain constant. There is nothing will affect to me. There is nothing will affect to me because between point A and point B, there is no forces, no moment, no anything, right? So I will remain the same. To here. Okay. Clear? Now I reach to the point B. Okay? Point B contains two things. The first one is the force, the second one is the moment. And we declare that the moment does not affect on the shear. Right? So we just have the effect of the force. The force was 50. Right? So you have 41.5 and it's positive. And there's a minus 50. So you should go 41 minus 50 and this is equal to 8.5, right? 8.5. So I will go to minus 8.5. This is a minus 8.5. Clear?
Yes.
Okay, now between point B and point C, there is nothing act, right? No forces, no moment, no anything. So there is nothing can act on this one. So I will remain constant again. I will remain constant again. Is that clear?
Yes.
Okay, perfect. Now, in the point C, when I reach point C, between point C and point D, I get a distributed load, right? And the value for this distributed load is what? Is 20, right? It's 20. So, and it's a minus 20 because it's a download. So I have minus 8.5 and minus 20, right? So the result is minus 28.5. It's a minus 28.5, right? Minus 8.5 and minus 20, minus 28.5. And it's distributed according to the table. I should draw a line like this.
Yes.
Right? So it's a minus 28.5. So I go down. Clear?
Yes.
Any question? Cool. Now, between point D and point E, there is nothing to act on the force, right? So, yeah, perfect. I will remain constant, like this. Cool. Now, I have inclined force, right? The X component does not affect on the shear, but the Y component will affect on the shear. So the Y component, it's upward, like this. This component was 50. It's a 100 sine 30, okay? It's a 50. So you have a 50 positive. So now, plus 50 will equal to 21.5, right? So I will go up to 21.5, right? Now, between point E and point F, there is nothing act. So I will remain constant, like this. Finally, at the point F, I have a 21.5 downward, right? So this one minus 21.5 will equal 0. So, and it's closed. The final value is 0. That means my drawing is correct, right?
Yes.
So, positive, negative, 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 positive. This is the shear diagram. Is it easy?
Can I ask a question?
Yeah, you can ask.
On the test, can we draw it like this, just like the right height and long?
No, it's you can draw freely
Okay.
without any skill.
Okay.
I just need the magnet, okay? And these lines, by the way, these lines, it will be given to you in the paper sheet. I will be drawing it. Everything is drawn. You just need to draw. Okay? Okay. Is that clear for the shear diagram?
Yeah.
Any questions so far? Perfect. Now, let's move to our second friend, the moment diagram, and clear all of these. moment bending diagram. Positive, negative. Okay? By the way, it's in books or other references, there is some authors or some engineers who draw the positive down and the negative up. It's okay, it's up to you. You can choose where is positive and where is negative. Okay? Now, let's go back. In this area, in this region, okay, this one, 2 meters, we should calculate the area, right? So, it's rectangle. How much the area for this one? Because the moment mean is the area under the curve, right? So the area here is 41.5 multiplied by 2. So A will equal, it's how much? 83. It's 83. It's 83, okay? And it's a positive area, okay? So now I was here, okay? I'm 0, and at this region I should end with 38, right? 83, yes. Okay, I write it 83, but I said it 38. It's okay. I hope in the exam you will do it well, okay? Okay, so 83. Now, how should I move from this point to this point? Curve, line, what do you think? You think a curve, okay. Anyone? Yes, it's outline, it's just outline.
This line.
Just line. Why? Because here it's a constant, right? This line here is a constant. When you make an integration, it will be from the first degree. So it's a line. Right? Clear? Perfect. Now, the second region is here. The length of this region, again, it's 2 meters. So let's calculate this area. This area. So the area here is 2 multiplied by 8.5, it's 70, right? So
Yeah, and it's negative.
area is minus 70, right? Minus 70. Am I right?
Yeah.
Okay, but before starting with this area, with this region, we should not forget that we have a moment here, right? At the point B, we have a moment, and the moment was equal to 15, right? Is it clockwise or counterclockwise? Counterclockwise, right? And according to the table, when you have a moment counterclockwise, you should go down. So 38 here, 38 minus 15 goes downward. It should be equal to
Minus 17.
minus 68. It's equal to 68. 83 minus 15, 68, right?
Yeah.
Okay. So let's now go down here to 60. Okay, let's go to 60. Okay. Now this region area is a minus 70, right? Let's make it minus 70. It will equal to 51. It will equal to 51. So I'm here, and I should end it with here 51. And the line here is a constant. Do an integration. It will be
Okay.
line.
Line.
Again, it's a line. Why curve? It's constant, I say. Okay? And it's down because it's negative. The area is negative. So it's like this. Okay, after that, we have on this region this area, right? So let's calculate the area here. What is the area?
It's a trapezium.
8.5 plus 28.5 over 2 multiplied by 2.
Yeah.
Perfect. Exactly. So this is the area. This is the area, okay? Here it was 5.8. 8.5, sorry. And this one, 28.5, and this one is 2 meters, right? So the area here is calculated by, it's a half multiplied by 8.5 plus 28.5 multiplied by the height, which is 2. تمام؟ So it will equal to, this is this, it will equal to what? How much? 37 تمام 37 38 اوكي خلينا نضرب بالمسطره اوكي let's go back to English now 37 and it's negative right because the area here it's a negative area so we have a 51 I don't know if it's still in the camera yes perfect. So we have 51, right? 51 minus 37 is equal to 14. So I'm here and I should go here to 14, right? I should go to 14. And now the line is a line from first degree, right? So in the moment it should be curve from the second degree. So imagine that there is a line and draw a curve up to. Okay? Draw a curve up to. Okay, now for this area, it's a rectangle, right? So the area here is it's 28.5 multiplied by 2, so it's going to be 59, right?
Why the curve it's not like this?
Not like this. Okay. This is the third time I will say it.
No, but because it starts from a number and...
This is for the shear, for the triangle case, not for the moment case. Okay? Can I go forward?
Yeah.
Okay. So, the area here is 59. The area here is 59. Okay? So, 14 minus 59, 14 minus 59 equal to how much? 45 million, right? 45 million. So I should end with 45 million. And the line here is
57, not 59.
what?
57, not 59.
57. Where? Here?
Yeah, there.
Okay, 57. 57. So 14 should be 43. 43.
Yes.
Okay, thank you. So it's a 40. Okay, now I was in 14, I ended with 43, and it's a line. So in the moment it should be yes, straight line from the first degree. Like this, right? Perfect. Finally, I got this area, and it's negative by the way. Finally, I got this area, and it's 21 multiplied by 2. Multiplied by 2. And it's equal to 43. Yes. And it's positive, right?
Yes.
So minus 43 plus 43, it's a 0, right? So I should end here. And it's a constant, so it's a line. Right? So positive, 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 negative, negative. This is the moment bending diagram for this beam.
The moment bending diagram and the shear force diagram should always start at 0 and end at 0.
Yeah, not always start with 0, because this one is not start with 0. Start with the 41.
They should always end at 0.
Yes, end with the 0. You should end with 0. Is that clear?
Yes.
You can write. Does anyone have a question? Are you sure? You want to go?
Yeah.
How much is that?
40.
Okay, you can go. You can go.
I hope this is recorded.
Yeah, I hope to. I hope to. Yes, it's recorded. Yeah.